Hi everyone, my name's Kira Proctor and I'm the Managing Director of the A Proctor Group Limited. First of all, I hope everyone's keeping well, that you're fit and healthy and that you're managing to make the best of the strange situation which we find ourselves in. As we're currently locked down, we thought it'd be a good opportunity to review some of our series of webinars and run some new question and answer sessions with our technical team. We're running this from our home offices, so please bear with us. There may be a couple of hiccups, but hopefully everything will go smoothly. This is actually our first webinar, which we ran a number of years ago, and so a lot has happened since. This is still one of our most popular webinars, so if you have any questions, just type them into the comments box or email them to webinar@proctorgroup.com, just as usual, and we'll discuss them after the presentation. Lastly, please bear in mind that when we're talking about these membranes and the placement of these membranes, we're discussing them within the context of the UK climate or similar climates, which are heated rather than cooled. So what are construction membranes? Construction membranes perform a variety of important functions within the building envelope. Although a relatively recent addition to building design, the pace of technological improvement and rate of adoption of such membranes is arguably faster than any other construction technology. With the performance requirements of both the membrane and the building improving all the time, ensuring the correct materials are specified is more important than ever. BS 5250 definitions. BS 5250, the Code of Practice for the Control of Condensation in Buildings, outlines when and where membranes should be used, along with ventilation requirements that may apply. BS 5250 is actually undergoing updates just now and is reaching the public consultation stage. It was supposed to be issued this year, 2020, but we'll have to see how that goes under the circumstances. We'll be putting out a webinar covering the changes as soon as it's finalised, so please keep an eye out for that. In the current BS 5250, the 2011 edition with 2016 amendments, the various type of condensation control membranes are defined as follows. Airtight layer. A layer which prevents the convective movement of air under the normal pressure differences found in buildings and which may also act as a vapour control layer. Breather membrane. Membrane with a vapour resistance of less than or equal to 0.6 meganewton per gram. Type HR underlay. Underlay which has a vapour resistance greater than 0.25 meganewton per gram. Type LR underlay. Underlay which has a water vapour resistance less than or equal to 0.25 meganewton per gram. Vapour control layers. Material of construction that substantially reduces the water vapour transfer through any building element in which it is incorporated by limiting both vapour diffusion and air movement. Ensuring these membranes are not only up to the required specification but are used in the correct position within the building element is important to ensure they perform the functions for which they are designed. Membrane types and functions. Breather. Breather membranes are installed on the outside of the insulated envelope. The membrane provides temporary weather protection during construction and secondary protection once the building is complete. Breather membranes usually contain hydrophobic additives, meaning they actively repel liquid water. The vapour permeable nature of breather membranes ensures any moisture within the construction or originating from the building use or occupants can escape to the atmosphere as easily as possible. Insulation. Insulation prevents heat loss from the building envelope. However, if the specification is not carefully considered, this can lead to moisture vapour becoming trapped in cold areas, which can give rise to condensation. Vapour control layer. The vapour control layer is installed internally, where it helps prevent this condensation by ensuring that the amount of moisture vapour entering the building is minimised. Membrane performance. In addition to ensuring membranes are in the correct position, the correct technical performance is also important. Breather membranes. Breather membranes are typically engineered plastics such as polypropylene or polyethylene. BS 5250 defines the breather membrane as having a vapour resistance of below 0.6 meganewton per gram. However, for roof applications, this must be 0.25 meganewton per gram or lower. Breather membranes used in roofing applications are typically referred to as vapour permeable underlays, and vapour permeable underlays can either be airtight or air open, which will have an effect on the ventilation requirements of the finished roof. Vapour permeable membranes are always used on the cold side of the insulated envelope. In the UK, that's nearly always the outside of the building. Vapour control layer. Vapour control layers are generally polyethylene. However, if higher performance is required, this is usually supplemented with a layer of aluminium. The performance required from a vapour control layer is more closely linked to the building usage than is the case for breather membranes. Low-risk applications which are less humid, such as warehouses and industrial units, will typically use VCLs with a resistance of around 125 to 250 meganewton-seconds per gram, while higher risk applications such as swimming pools may require resistances as high as 44,000 meganewton-seconds per gram. Vapour control layers are always installed on the warm side of the heated envelope. Again, in the UK climate, that usually means the inside. Not all membranes are the same. While there's a degree of overlap in the functions of the various types of membrane used in construction, the differences between them can have a significant effect on how they are used. Air Vapour Permeable membrane. SMS breather membranes comprise a core layer of melt-blown polypropylene sandwiched between two layers or spun-bond polypropylene. These outer layers help provide additional water resistance as well as protecting the core from physical damage. The fibres in the melt-blown core are many times smaller than human hair, giving the membrane a microporous structure which allows water to pass through as a vapour but not as a liquid. This type of membrane has the most open structure and hence the higher permeability to water vapour. The open structure also allows air movement through the membrane, which boosts the rate at which vapour can escape a roof and significantly reduces the likelihood of condensation occurring. The relative weakness of SMS membranes is their water resistance, which, although more than adequate for their use on roofs, is lower than that of other membrane types. Airtight Vapour Permeable membranes. Film laminate membranes use a film core layer in place of the melt-blown fibres. This film is sandwiched between carrier layers, which are typically similar to those used in SMS membranes. As before, these outer layers help provide additional water resistance, while as protecting the core from physical damage. This film allows moisture vapour to pass through, but provides a barrier to both liquid water and air. The water holdout properties of this film core mean that these membranes typically offer higher levels of water resistance than air permeable materials. However, this comes at the expense of a greatly reduced vapour permeability. Vapour control layers. In comparison to breather membranes, vapour control layers are relatively simple. Most vapour control layers are polyethylene and or aluminium, with no perforations to ensure vapour resistance and airtightness are maximised. Some vapour control layers add a layer of reinforcement to prevent tearing, and these reinforced membranes are generally preferable as the performance of the membrane is only as good as its continuity. Unreinforced membrane can tear and stretch unless care is taken during installation. Variable resistance vapour control layers. Membranes like our ProCheck Adapt are a more advanced evolution of the standard VCL. These membranes use specialist materials that respond to changes in humidity by varying their vapour resistance characteristics. The vapour permeability reduces over the cold winter months, allowing the membrane to resist the ingress of water vapour, then increases in the spring, allowing warmer summer temperatures to dry out the building fabric more effectively. Types of roof. Traditional ventilated roof. This shows a traditional type of roof construction using a type HR underlay as defined in BS 5250. This type of underlay includes a traditional bitumen roofing felt as well as more modern plastic equivalents. In this type of roof construction, vapour cannot escape through the membrane at all and therefore must be removed from the roof by means of ventilation openings. The exact specification of this ventilation varies, but typically vent openings are provided at the eaves of the roof and again at the ridge. While effective and proven over a long time period, this type of roof is susceptible to vents becoming blocked, for example, with items stored in the loft. And for more complex roof configurations, ensuring adequate airflow throughout can pose challenges. Type LR underlay, Airtight. Airtight LR underlays improve the situation by allowing vapour to escape through the entire roof surface, not just through ventilation openings. This reduces the likelihood of vents becoming blocked. However, airtight LR underlays do not always have sufficient vapour permeability to eliminate the need to ventilate altogether. This is particularly true during the initial phase after construction, when there is a significantly higher moisture load from wet trades known as the drying out period. It is therefore common to see airtight LR underlays require 5 mm of ridge ventilation to assist in the removal of vapour. They also usually require the ceiling to be well sealed or a vapour control layer to be used at ceiling level. Type LR underlay, air permeable. By providing, to quote the BBA, a significant additional mechanism for water vapour egress by convection, air permeable membranes such as our roof shield can always be used with no additional ventilation, as both air and vapour can move freely throughout the entire roof surface. This additional permeability means no vapour control layer is required at ceiling level, and no openings are required at the ridge. This type of roof construction provides a simpler and a more robust solution, with less likelihood of incorrect ventilation or ceiling specification or installation. As long as the air open underlay is installed correctly, the risk of condensation will be minimal throughout the life of the building. External air barrier membranes. One of the more recent construction membrane developments is the use of external air barrier membranes, which represent a significant departure from accepted traditional practice. Traditionally, the vapour control layer, being inherently airtight, has performed the function of the airtight layer in the construction. While this solution does work, it places a lot of emphasis on the quality of installation and sealing of the membrane, which can be difficult and time-consuming. Moving the airtight layer to the outside of the heated envelope presents a faster, simpler and more robust solution. Nearly all vapour control layers can also be used as an internal air barrier membrane, which simply requires that the membrane is both air and vapour tight. On the external side, however, not all vapour permeable membranes are suitable. Air permeable breathable membranes are not suitable for this application, and while mechanically fixed external air barriers are common, more advanced self-adhere types will maximise the benefits. When using membranes of this type, it is important that vapour control is carefully considered. It may be necessary to limit moisture vapour transfer, for example, by using a well-sealed vapour-tight insulation board. External air barrier benefits. The main benefits of external air barriers are in the installation process. Internal air barriers must be sealed throughout all surface penetrations, structural elements and openings throughout the structure, which adds considerably to the time and cost of the installation process. Each of these seals also represents a potential point of failure in the airtight layer, which may not be discovered until the membrane is covered by internal decorative finishes, making remediation complex and expensive. Failure to meet the design air leakage rates can have a major effect on the energy performance of the building. Moving the air barrier externally hugely reduces the amount of sealing required, increasing the likelihood that air leakage targets will be met. This in turn allows the use of more ambitious air leakage rates at the design stage, giving significantly improved design flexibility in other areas such as thermal insulation. Case study, Kingspan Potton. The benefits of an external airtight layer were proven on a site trial conducted by Kingspan Potton. They utilised the Raptite self-adhered vapour permeable membrane as an external air barrier. The Raptite product itself is highly vapour permeable, yet airtight, acting as an air barrier, and it's self-adhered to ensure continuous layer can be achieved easily on site. The project was a timber frame house which was targeting an air leakage rate of 0.6 air changes per hour, which is essentially a passive house. Raptite was used externally as a combined breather membrane and air barrier. Alongside that, the Raptite tape, which is a very similar product, was used to seal surface penetrations, window frames, etc. This achieved and is consistently achieving 0.5 air changes per hour with no remedial actions required. You can see Dr. Paul Newman was very happy with the result after quoting, "We had a positive experience using Raptite on this project and look forward to further exploring its potential to help us construct premium performance building envelopes." Benefits of airtight construction. Building regulations compliance in the UK is assessed via the carbon dioxide emissions of a building. Taking domestic buildings as an example, this is called the dwelling emission rate, or DER. The DER is a holistic value that incorporates the effects of all the energy performance measures included in the building design. This allows characteristics such as air leakage rates, thermal insulation levels, areas of glazing, and renewable energy sources like PV panels to be traded off. In our example, achieving a 6% improvement in DER would mean increasing the thickness of insulation from 130mm to 360mm, which would have a significant effect on the building footprint or the internal space. In contrast, by improving the airtightness of the dwelling, the insulation thickness can remain unaffected. Taking the pressure test results from 7 down to 1 will result in the same 6% improvement in DER. With the latest generation of self-adhesive air barriers, this degree of improvement is not difficult to achieve and will be highly cost-effective compared to adding over 200mm of extra insulation. The primary benefit of a product such as Raptight in this application is to make these low air leakage rates easier to achieve and hence more dependable. This in turn means more ambition performance trade-offs can be made without fear of failing to achieve the specified design target. So in summary, there are many differences in performance characteristics between the different types of membranes. Ensuring the correct membrane specification is used and in the correct position is an important aspect of the design process. As building designs become more optimised and efficient, the focus then shifts to ensuring that as-built performance matches the anticipated at the design stage, and construction membranes play an important role in ensuring that happens. So we'll now move on to the Q&A session. Hi everyone, I hope you can hear us okay. I just want to check that all my team are currently unmuted. Can I just say hi to Sue and Mark?
Hi, Kira.
Morning, and morning to everyone that's joined our webinar. I know it's a little unusual. Obviously, we're all here working at home. And first of all, I just want to say, hope everyone's healthy, happy, and well. That you're coping with the lockdown in the UK, and try and make the best for Easter. We have received quite a number of questions, so 10 plus, and if you can bear with me, because I've had a number through email, through direct message on Twitter and on the YouTube channel. Usually I've got someone over my shoulder telling me what one to ask when, so just bear with me. But in case you have to go before we go through the Q&A live session, just a few things. Obviously, thank you very much for joining again, and we hope you found it informative and educational. You can receive a personalised CPD certificate, which will be through our website. So if you go to proctorgroup.com/webinar-certification, you can sign up for that. We are going to be doing webinars every Friday. So Friday the 17th of April is our next webinar, which will be on space therm aerogels in building refurbishment. So I hope you can make that. We will send out various emails and reminders to everyone here that has joined. Just on the CPD certificate side, you will get an email following up with instructions how to do that. A replay of the webinar, so please feel free to circulate it to your colleagues, anyone who may be interested, and also a feedback form. We find it really useful when people can fill these out to shape the next webinar that we do, the forthcoming webinars, and any constructive feedback is very much appreciated. So welcome Mark and Sue. Mark is our business development manager, and Sue has been in our technical team for a number of years now. So I will start away. So Mark, this is a question from John, and that we received through email. Are there any restrictions on the type of substrate Raptight can be adhered to?
Right, morning everyone. Yeah, Raptight self-adhesive membrane is suited to a range of substrates, and these would include sheathing boards, typically used in high-rise residential or modular off-site construction. So these will be products such as cement particle board or gypsum-based alternatives, as well as engineered timber and traditional blockwork. Now, irrespective, I guess, of the substrate type, Raptight does not need a primer. However, as with any sort of adhesive-based product, preparation is key, and clear advice is given in our user guide, which accompanies both every delivery to site, but is also available for download off the website. In addition to that, really, I guess that our external teams are also available to provide toolbox talks at the job site, and this makes sure that the guys are sort of following best practice. And in addition to that, we offer compliance checks, so during the construction phase, to give confidence that Raptight is being installed correctly and will perform as designed.
Okay, thanks, Mark. Okay. I'm just trying to see if there's any other ones that have come through on that same topic. So from James, Mark, would something like Raptight be beneficial over blockwork as an air barrier in place of a parge coat?
Well, being fully self-adhered, Wrap-Tight would certainly be quicker to install. There obviously be reduced labour costs. The thing with the Parge coat, you're introducing a wet trade into the construction, so you've got to think about considering out the drying out process. And on a solid masonry wall, Wrap-Tight would certainly be more breathable than a gypsum-based Parge coat or sand cement and that type of thing.
Okay, great. Thanks, Mark. Sue, we have a couple here. What impact does the Scottish roof detail of sarking have on these two types of roof layer? And I believe this one was asked around the time when we were talking about the air permeable and airtight.
Okay, like the traditional sarking board is something that is obviously a traditional form construction, certainly up here. Roof shield, being air permeable, can be used over traditional softwood sarking or even sheet sarking in warm roof constructions, which is where the insulation follows the line of the roof. Absolutely no issue there. Cold roof construction, again, with traditional sarking boards, roof shield can be used there without any additional ventilation requirements. With Wrap-Tight, because it is a self-adhesive membrane, it obviously has to be fully supported. So again, in warm roof applications, it's covered by BBA certification. So it can be fully supported over softwood sarking boards, over sheet sarking boards, or even over insulation itself, provided obviously the insulation again follows the line of the roof.
Okay, perfect. Well, that's great, because we had a question from Stephen whether Wrap-Tight could be used on roofs as well as walls. So you've just answered that, so that's great. Sam has asked, can I mix warm and cold roof elements when using roof shield, like in a room in the roof?
Absolutely. Where you have insulation in between the cool section following the line of the roof, and then your cold sections usually at the eaves with the insulation down at the middle. Roof shield can be used in that application again without any additional ventilation requirements. Unless you're using sheet sarking boards, there is a slight difference there. Traditional sarking boards is fine, sheet sarking boards is slightly different. But as I say, we do have BBA certification for room in the roof applications such as this. So there's no issue there. If there's no sarking boards at all, and it's your traditional open, like your open rafter design with tiles, then no issues at all.
Okay, perfect. And last one while we've got you, then we'll give you a break, Sue. James, is currently working on a re-roof for a historical property. Would using roof shield therefore mean I don't need a VCL and can leave the existing ceiling intact?
Yes, potentially, depending on, obviously, if it's a historic build, depending on what the actual construction details are. Roof shield is absolutely ideal for that situation. The air permeability, the vapour permeability means that if the ceiling is intact and it can't be removed, then there's no need to put in that separate vapour controller.
Okay, great. Okay, Mark, there's a couple of more sort of generic about vapour and air here. So first of all, from Lillian, how does temperature affect vapour transfer? i.e., what if the external air temperature is below freezing?
To be honest, Kira, that's one more for Sue, I think, than myself.
Sorry, Sue.
Yeah. Say that again, Kira.
How does temperature affect vapour transfer? So if the external air temperature is below freezing, for example.
Well, the temperature, the dew point, you'll always have from warm to cold anyway. So if it's colder on the outside than it is on the inside, the vapour drive will always be naturally in that progression anyway.
Okay, good. This is why we have the technical backup team, you see?
Yeah.
Come in handy. Does air permeability, this is a question from Ahmed, does air permeability affect wind uplift, Mark? Is that one for you?
Yeah. Well, wind uplift forces on the roof system is really an important factor to consider, I guess, with roof design and particularly underlay specification. So this is covered by BS 5534, which was revised in 2014. So the resistance to uplift forces is shared by the outer covering and the underlay, and it really depends on the air openness of both parts. So in extreme cases, you can see there was the potential for the tiles of the slates of the outer roof covering to actually be damaged by those uplift forces. So that can directly sort of remove the slates or tiles by sucking them off the roof. And it's believed by some in the industry that roofing underlays could also be the cause of this, by sort of the membranes ballooning up under that wind uplift, and in theory pushing the tiles or slates off the roof. Now, I guess bearing in mind that Roof Shield was launched way back, what, in 1996, so there is little, in fact, no conclusive evidence that this has ever occurred, especially with Roof Shield. However, there was an amendment that was put place in BS 5534 in February 2018, I think it was, and that sets criteria for the underlay in terms of resisting wind uplift forces, and they've now divided the UK into 5 wind zones. So if you go on our website, you look at our data sheets, it will tell you exactly where Roof Shield can be used. So effectively, in zones 1 to 3, there are no special measures required. And with Roof Shield, you can have batten spacings at 345mm. In zones 4 to 5, it tends to be the Scottish detail. But even so, if you are in more sort of remote areas, you can reduce those centres down to 250mm, or perhaps use 11mm counter batten, or even a tape over the laps. If it's a Scottish traditional detail of putting the slates through the membrane into the sarking board, then there's no restrictions at all. So it doesn't really affect permeability with regard to wind uplift at all.
Okay, great. Right. Here's another Roof Shield one, which is through Twitter DM, which I'm on my mobile with, so bear with me. Another Roof Shield one, Mark, if you can take this. Does timber sarking affect the use of Roof Shield? Can I use OSB or plywood?
Well, the traditional approach has always been, as we said earlier, using softwood planks around 150mm wide, and these are installed with 2mm gaps. So that allows, particularly with Roof Shield, you've got the air movement through the membrane, but it easily allows water vapour to get out of the roof system through to the primary roof covering and out to outside atmosphere. Where you've got sarking boards which are OSB or plywood, these things tend to be manufactured using binding agents and adhesives. So if you can imagine these being compressed under load with all these adhesives in, then this has a high vapor resistance, and it has a big impact on the way that moisture will flow. So you really need to look at the membrane certification to see what additional requirements or restrictions are needed if you're using OSB or plywood.
Okay, good. Now back to Airtight. Stuart's asking about, which is a good question. So I think I missed this in the feed as we were going there when we were talking about substrates. What about Airtight adhering to wood fibre board? And he's asked with or without primer.
You may have to do a test on it. Certainly on the face of the board, it wouldn't be an issue. You might find that on the edge of the board, where the fibres are sort of exposed, you may need to put a primer on there. And I think certainly there are some window details where there's a primer that are being used. So we'd have to look at each of those on its own merits, as it were. And certainly if you forward information to our technical team, the guys can have a look at that. And as I say, we can do some trials if necessary. But overall, it shouldn't be an issue. Airtight should bond fairly easily to wood fibre material.
I mean, we've had a number of projects with mineral fibre, haven't we, which has been problematic. So I don't know if we've done an external test on a wood fibre, Sue, but we wouldn't anticipate any issues. We know it's been used in those applications, but we could maybe look into something official actually as a action point.
Yeah, absolutely.
Okay, DesignWorks has asked how to fix, I presume that's breather membrane over external wrap of PIR insulation. Not a mechanical fix, but self-adhesive. Sue, is that one you want to take?
Well, it's probably an ideal application for the Airtight then being self-adhesive, which, negates the requirement for any mechanical fixings you like to fix the membrane into.
Yeah, so maybe they were asking, I presume there's no issues. Well, we know there's no issues, of course, with Airtight adhering to a PIR insulation board because it's used in a lot of commercial applications and actually domestic on the full fill system. So there wouldn't be any problem with that. Scott has asked, do you offer guidance for the safe cutting of your insulation products? We find that your space down products, when cut, release insulation fibres into the immediate air. Well, yes, we do. Sue, is that something that you want to cover in a bit more detail?
Yes, we do have installation instructions for all our Space Therm products on how to cut. It is a dusty product, so we do advise obviously cutting it in a well ventilated area, like preferably outside if possible. The dust is harmless. We have cutting instructions, we have health and safety data sheets, etc., that are all available for download or for online.
Yeah. So again, Scott, if that's something you're more interested in, there's a lot more detail about the technical makeup of the Space Therm air gel products a week today at the same time. So please join us. A couple more that have come via the email, then I'll come back to the YouTube feed. Just bear with me. Glynis has asked, how can Wrap-Tight remain airtight if it's being punctured by cladding rails, etc.? Sue, is that what you want to go over?
Yeah, Wrap-Tight, the base material of Wrap-Tight is a spun bond material. So basically, when it's mechanically punctured, the fibres actually just move apart rather than it piercing. So it creates a bit of a seal around a fixing. Being self-adhesive as well, the adhesive on the back side of the membrane will also create a seal. Added to that, we have our liquid flashing, which can be used around any sort of like larger pipe penetrations, vent penetrations, etc., just to create that additional seal for airtightness.
Okay, good. Chris, much of your literature and discussions are relating to traditional construction methods that follow the general rule of reducing vapor resistance from warm to cold. Have we looked into and tested any products for some of the more modern methods? Let me start again. Have we looked into and tested any products for some of the more modern methods of construction, such as single skin precast, which do not follow this general rule? Either of you? Is that something that you know about?
We're obviously always looking at different forms of construction, newer types, etc., such as obviously CLT, which is, I had a discussion with somebody not that long ago with Wrap-Tight. The good thing about Wrap-Tight, obviously being Vapour Permeable, is that it doesn't create a risk of condensation in a construction. Because the vapour is able to pass through. What we would do is obviously look at any new builds or new constructions, or send us through the details. We'll have a look at them and we'll be able to come up with a solution.
And is that something so that we would use our software, WIFI, obviously condensation risk analysis software? So we have these tools in-house which the technical team do on a regular basis. We also do just talking about sort of warm to cold and different areas of vapour transfer. We do a lot of work in the Middle East and in different climates, such as Australia, where we have partnerships. So again, these are WIFI calculations and different software that we can do to look at the particular climatic, not issues, but the climatic conditions that these different geographical areas have, or the constructor may have, and we can come up with a risk-free solution, utilising our products or not. A lot of the times it'll come out and perhaps the advice won't be a Procter product, but that's how we tend to do things up at head office when it's open, when you're open. Okay, great, thanks. Really good questions. How do you overcome the excessive use of silicon, the fire-rated type, between sheathing boards? Nothing sticks to silicon except silicon. This is Rob Hallowell. Have we come across silicon being used? I presume these are the Wrap-Tight applications?
Not silicon, not myself. I don't know whether you've come across it, Sue.
No.
We can certainly, on high-rise residential projects where you've got, say, a concrete frame, we're replacing a lot of the EPDM that was traditionally used along the floor at zones and in concrete columns, etc. With the Wrap-Tight, so we can dress that over with a simple detail to allow for deflection, etc. So we've managed to reduce the amount of flammable materials, as it were, that are being used on some of the high-rise projects. And we, of course, have a liquid flashing that it can be used for more difficult sort of detailing, but I've not come across an issue with silicon, so I can't really comment on that. We'd have to do testing, I guess.
Okay, on that one, presumably, let's say silicon, this fire-rated type of silicon is being used between sheathing boards. Presumably, though, it would be such a small section of that entire board that when the Wrap-Tite was adhered to the sheathing board, you would think,
wouldn't cause an issue.
Yeah. Oh, okay, high-rise semi at GTAC or similar. Okay, that's good. Thanks for the clarification, Rob. Yeah, our product has been used on Cineat boards without issue. Now, whether that particular material was being used between the boards, we obviously can't tell you. Someone else in our team may know, so I think it's a good question for us to take afterwards and ask if they've come across it, and we can certainly email with more information on it. Okay, so a couple of questions on fire here. So a general one from Sarah, do these membranes contribute to a fire risk? So I presume that means all the membranes, all the different types of membranes that we've spoken about.
Yeah, sure. When considering the fire risk, all parts of the construction should actually be taken into consideration. However, it's generally agreed that membrane itself will not, because it's such a small part of the construction, will not greatly add to the fire load. However, we do, obviously, there are situations where certain fire performance requirements are needed, such as in high-rise buildings, 18 metres in England, 11 metres in Scotland, where there is a minimum requirement of class B S3D0, which the membrane must comply with. Now, we've got several membranes in our range that do exceed that minimum requirement, whether you're looking for a vapour permeable membrane or an impermeable vapour control layer.
Okay, great. And Mark, Jill has asked, vapor controllers are generally manufactured from polyethylene, which is, are fire-rated products available?
Yeah, yes, certainly. We've got a couple of products within the range. We've obviously seen an increased demand from specifiers and contractors for fire retardant membranes, including vapour control layers, certainly for high-rise building applications. And when you consider with the Scottish regulations, they consider buildings over 11 metres high-rise, and in England and Wales, we're looking at over 18 metres. So we've got two products to offer. One is ProCheck FR200, which is a sort of a reinforced foil-faced vapour control layer for roof and wall structures, new build or renovation projects, and has a reaction to fire of a class B, S1 for smoke, D0. So it exceeds that minimum classification of B, S3, D0. And then we've also got ProCheck A2, which is a high performance membrane with an A2 rating, A2 S1 D0 fire classification. And that consists of a laminated glass fibre with an aluminium foil. And that aluminium foil is protected by a sort of a clear lacquer, and it offers a unique low emissive surface. So if you're installing that within a service cavity, minimum depth of say 19 mil, it will provide additional thermal performance to the overall wall construction. So when we're doing the U-value calculations, condensation risk analysis, and indeed woofy calculations, we can add that additional thermal performance to the overall wall construction.
Great, thank you. Just from Rob here, sorry, explaining what the silicon looks like, more like a baked Alaska. It's giving me the giggles. Yeah, I can picture it on a building. Now, thank you, Rob, for clarifying.
Yeah, Kieran, I mean, the guys, they tend to hate with a passion trying to install that between the board joints. So it's been good on the projects where Airtight has been used. As you said earlier, it just simply goes over the top of the sheathing boards and over that without any issue at all. But it just adds that confidence that we're going to achieve the airtightness.
Yeah, good. Okay. Michael's asked, okay, good question. Can you identify by sight the difference between a breathable roof belt that needs ventilation and one that doesn't? Well, I mean, the answer to that, unfortunately, is no, because from the outside, generally, the breathables tend to all look the same. If it's green and it says roof shield on it, then yes, you can, if you happen to drive past that. But to be fair, I mean, there's hundreds of breathable roofing membranes on the market. And there's a very, very small number of air permeable membranes which either don't or claim to not require ventilation. So I think I'm correct in saying, I mean, there's no way really to identify it from externally, right, guys?
Yeah.
Okay, good. Vapor control layer is an internal wall lining sandwiched usually between a fire-resistant wall. Approved document B does not single out a VCL. It's not part of the internal. That's not a question, is it? Is that a question? I'm confused by this one. Can you guys see that one on the YouTube feed?
No.
No, not got it up here. So.
I'm just looking to understand that. So VCL is an internal wall lining sandwiched usually between a fire-resistant wall. Approved document B does single out a vapor control layer. It's not part of the external wall buildup. Okay, yeah, so I do understand that, but I'm not really grasping the question. So Rob, if you want to come back and clarify that one a little bit, if it is a question. Okay, sorry about that.
I guess he's referencing breather membranes because they are sort of under Part B and the classifications required.
Right,
so,
going back to the previous question.
Yeah, the external wall detail. So I guess he's talking about that internally. As I say, we have seen this increased demand for fire-rated VCLs. Whether that's just a knee-jerk reaction or a misunderstanding of the classifications, etc. I don't know, but certainly there's a huge demand for it.
Yeah, I mean, it's interesting for us because obviously with our business in the Middle East, we've been providing fire resistant vapor control for a number of years, going back sort of 5-7 years, in fact. And sort of tried and tested. So our vapor controller is actually on the redo of the address. If anyone remembers that New Year's Eve when the address went up in flames, which is a very iconic and quite famous building in Dubai, our product's on the external face of that. Of course, in a different position because of the reverse vapor drive, the vapor controller, of course, goes on the external face of the building. So we have a lot of experience in fire-rated membranes because of the different business we do in different countries. And what we have done is really introduce these into the UK market, given the drive for new solutions to some of the challenges we have with fire moving forward after the horrible tragedy that happened at Grenfell and a few other buildings, of course. So if you do have high-rise buildings which you're concerned about that you're working on and you want to just explore some of the fire-rated options, then we can help, and we can obviously help direct you in the right route for that. Okay, great. I'm just trying to look. I think there's a couple more through email. I think there's 2 more emails. So if there's any others, please continue to post on YouTube. And I'll check the Twitter DMs in a minute. So what are the implications of using Airtight to reduce air leakage in refurbishment projects? Sue, that's a question from Derek.
Yeah, Airtight certainly can be used in refurbishment projects as well. Will certainly improve the air leakage factor, will prevent drafts as well. Obviously, with an existing building, there may well be some inherent conditions that you have to deal with that you can't design out. But we would look at those on an individual basis and obviously offer advice and sort of like installation guides, etc., as to what is the best product to be using in this type of application.
Okay, good. Gary has asked, I managed to skip past this one, sorry, I'm not the best multitasker. Do you have an equivalent to the Proclima Intello Plus Vapor Check membrane for use with mineral insulation?
We do. That would be our ProCheck Adapt, which is a variable vapor control layer. So it works differently depending on the conditions. So it can be more vapor open or vapor closed, depending on the conditions that are actually occurring at that time of year. So yes, that would be our alternative.
Okay, great. Thank you very much. Okay, back to a roof shield one now. In fact, yes, I think I haven't asked this one. Can I slate through your roof shield using traditional Scottish practice, nailing through membrane into sarking?
Yes. Yeah.
Yep. Okay.
No problem. Yeah.
That doesn't create any water ingress problems, or?
No, I mean the roof shield being air permeable, the core obviously self seals as you're driving the fixings through. So as I said earlier, the product's been on the market since 1996. We've had no issues or problems with water ingress through that type of application.
Okay, good. Excellent. Okay, I'll just have a quick check of the Twitter and make sure there's no other DMs. So many different platforms now for people to send questions through. It's good. It keeps me on my toes. No, there isn't. So great. A few people saying thank you for the interesting webinar. Lovely to read. So we really appreciate that. Thank you to the marketing team who aren't on a camera here, but they've been working away at this, and they're now probably started work on the webinar for next Friday, which is the aerogels in building refurbishment. Now that's a really interesting one. We also have some aerogel products for well, of course, aerogel products can be used both in building refurbishment and new build. And we have recently introduced an A2 space therm solution for fire applications, which again, very interesting. So we'll try and update the webinar to make sure that we can include that content. One last question has just come in very quickly. When using an air open membrane, do you recommend the use of a VCL when the ceiling board is fixed to the rafters? Sue?
With roof shield, which is obviously air permeable, allows air to pass through and obviously vapour to pass through. Generally what you're looking at is you're looking at the whole construction. So provided the ceiling is convection tight, and that could be by means of you know, like the insulation boards, the type of insulation that you're using, etc. It's not necessary to have a separate vapour controller.
Okay, good. Thank you very much. Right, so that's all the questions. So first of all, thanks for being so interactive with the questions again. I always think it's good to have the live Q&A at the end. It also gives us an idea of the type of questions that the market are interested in, so that then we can go back and make sure that our website content, our sales team, etc., are prepared to answer these type of questions, which is great. Just to reiterate, CPD certification is available on the website, and we will be sending an email. A couple of people have asked, is the presentation available afterwards? Yes, it is. It will be emailed to you, and if you don't receive it, please email our team at technical@proctorgroup.com. So if for any reason you don't get the follow-up email, please email us, and we'd be very happy to send it to you and circulate it to as many of your colleagues or whoever, husbands or wives, as you like. Feel free. Again, another reminder, our next webinar is the same time a week today at 10 a.m. On 17th of April, space therm aerogels in building refurbishment. We booked this on Good Friday by accident. We didn't realise. We've all lost track of the days because we're working from home and trying to remember, you know, when the weekend's coming. So I'm very pleased with the turnout. So thank you all for joining. You on the email for, you know, the follow-up email, you'll receive a request for feedback. Again, please fill it out, be as honest as possible. We will not be offended. No name calling, but we'll try not to be offended, and we'll take anything constructively and apply it to the next webinar that we're doing. And I think that's it. Yeah, thank you very much to marketing team. Thank you to Sue and Mark. I've been seeing you every couple of days anyway on our team catch-ups, but it's nice to see you this morning and put you on the spot with some questions. And wishing everyone a really fantastic Easter weekend, including, I know there'll be a few Proctor staff on here, including you guys, missing you all at the office. We do still have, you know, a technical team working, sales team working. Got a number of people who can help you with any of your questions about our products or about any questions you have on your projects in general. So please contact us. We're here to help. Call the head office number and it'll be filtered out to the home offices where our staff are working, or email us and we'll get back to you quickly. So have a great weekend. Thank you very much indeed. And we hopefully will see you a week today for our next webinar.
Bye.
Okay, thanks guys. See you later.
Yeah.
Bye bye.